Our planet is facing a challenge of unprecedented scale climate change. The burning of fossil fuels like coal and oil releases harmful greenhouse gases into the atmosphere. These gases trap heat, causing our planet to warm at an alarming rate. The consequences are already being felt across the globe, from melting glaciers to extreme weather events. The impact of climate change is undeniable. We are witnessing more frequent and intense heat waves, droughts, floods, and storms. These changes threaten our ecosystems, our food security, and our very way of life. It is imperative that we act now to reduce our reliance on fossil fuels and transition towards cleaner, more sustainable energy sources. The transportation sector is a major contributor to greenhouse gas emissions. Cars, trucks, and buses powered by gasoline and diesel release a significant amount of carbon dioxide into the atmosphere. To mitigate climate change, we must find alternative ways to power our vehicles. Electric vehicles, or EVs, have emerged as a promising solution to reduce our dependence on fossil fuels. Unlike their gasoline-powered counterparts, EVs run on electricity, which can be generated from renewable sources like solar, wind, and hydropower. By transitioning to electric vehicles, we can significantly reduce transportation-related emissions and pave the way for a cleaner, more sustainable future. However, the widespread adoption of EVs faces a significant hurdle: battery technology. Current lithium-ion batteries, while efficient, have limitations in terms of range, cost, and environmental impact. The mining of lithium, a key component in these batteries, raises environmental concerns. Moreover, the disposal of lithium-ion batteries poses a challenge, as they contain hazardous materials. To truly unlock the potential of electric vehicles, we need a battery technology that is not only efficient but also sustainable and environmentally friendly. Enter aluminum-air batteries, a promising alternative to conventional lithium-ion batteries. These batteries utilize the reaction between aluminum and oxygen to generate electricity. Unlike lithium-ion batteries, which store energy chemically, aluminum-air batteries produce energy on demand. An aluminum-air battery consists of three main components: an aluminum anode, an air cathode, and an electrolyte. The aluminum anode acts as the fuel source, while the air cathode allows oxygen from the air to enter the battery. The electrolyte facilitates the flow of ions between the anode and cathode, enabling the chemical reaction that produces electricity. When the battery is in use, the aluminum anode reacts with oxygen from the air, forming aluminum hydroxide as a byproduct. This reaction releases electrons, generating an electrical current. The aluminum hydroxide can then be collected and recycled back into aluminum, creating a closed-loop system. Section 4. Out with the old, in with the new. Aluminum versus lithium. Aluminum-air batteries offer several advantages over traditional lithium-ion batteries. Firstly, aluminum is an abundant and inexpensive material, unlike lithium, which is relatively scarce and expensive. This makes aluminum-air batteries a more cost-effective option in the long run. Secondly, aluminum-air batteries have a higher energy density than lithium-ion batteries, meaning they can store more energy for their weight and size. This translates to longer ranges for electric vehicles, addressing one of the key concerns of potential EV buyers. Moreover, aluminum-air batteries are safer than lithium-ion batteries, which are known to pose fire risks. Aluminum is a non-flammable material, making aluminum-air batteries less prone to overheating and fires. Lastly, the use of aluminum in these batteries aligns with the principles of a circular economy. Aluminum is a highly recyclable material, and the aluminum hydroxide byproduct can be easily collected and recycled back into aluminum. Section 5. A greener charge: environmental impact and research. From an environmental standpoint, aluminum-air batteries offer significant advantages over lithium-ion batteries. The mining of lithium for lithium-ion batteries has been linked to environmental degradation and water pollution. In contrast, aluminum is the most abundant metal in the Earth's crust and can be extracted and processed with a relatively lower environmental footprint. Moreover, the recycling process for aluminum requires significantly less energy compared to the production of new aluminum. This further reduces the overall environmental impact of aluminum-air batteries. While aluminum-air batteries hold immense promise, there are still some challenges that need to be addressed before they can be widely adopted. One of the main challenges is the formation of aluminum oxide on the anode surface, which can hinder the battery's performance. Researchers are actively working on developing new materials and designs to overcome this challenge. Section 6. Powering a Sustainable Tomorrow. The development and adoption of aluminum-air batteries represent a significant step towards a more sustainable future. By harnessing the power of aluminum, a readily available and recyclable material, we can reduce our reliance on fossil fuels and mitigate the impacts of climate change. These batteries offer a compelling alternative to conventional lithium-ion batteries, with their higher energy density, lower cost, and reduced environmental impact. While challenges remain in terms of performance optimization and scalability, ongoing research and development efforts are paving the way for the widespread adoption of this promising technology. The transition to electric vehicles is crucial for reducing our carbon footprint and combating climate change. Aluminum-air batteries have the potential to accelerate this transition, providing a sustainable and efficient way to power the vehicles of tomorrow.